Look at this mathematical expression. ml squared t to the negative 3 a to the negative 2. Out of context, it looks like an intimidating piece of alien code. Open any physics textbook, and you are immediately hit with hundreds of these formulas. Classical mechanics, electromagnetism, and thermodynamics present themselves as distinct, complex languages, leaving students to rely on rote memorization to bridge the gaps. But that approach masks a deeper puzzle. To see the true structure of the science, we have to ask how the electrical resistance of a copper wire relates to the physical mass of a falling apple. They seem like two separate realities. Yet, if we strip away the names of the units and look at the underlying math, we find they are built using the exact same architecture. By isolating just 7 base dimensions, we can derive the entire matrix of physical laws from scratch. Every law in physics, from the motion of stars to the flow of electrons, resides within this single, interconnected logical matrix. The International System of Units defines 7 fundamental dimensions: mass, length, time, current, temperature, luminous intensity, and amount of substance. Dividing length by time maps pure motion, velocity, Lt-1. Dividing by time again gives acceleration, Lt-2. Analyzing uniform circular motion, orbital mechanics, or free-falling bodies, they all share this identical dimensional footprint. This grounds us directly in classical kinematics. Galileo concluded that all objects in a vacuum fall with the same uniform acceleration, regardless of their weight. All pure geometry and motion, no matter how complex the trajectory, boil down to nothing more than variations of length and time. Kinematics shifts into dynamics the moment we introduce physical mass into our moving system. Watch what happens when we bring the base dimension of mass next to our derived acceleration node. Multiplying mass by acceleration produces a central node, force, written as mLt-2. This maps directly to Newton's second law: force equals mass times acceleration. Whether calculating the centripetal force keeping a car on a curve, the thrust of a rocket engine, or the tension in a pendulum string, the underlying dimension remains strictly locked to mLt-2. Isaac Newton used this exact mathematical relationship to quantify inertia, proving that the force required to move an object scales directly with its mass. Force acts as the universal dimensional currency that translates raw physical mass into movement across all physical systems. The system scales further. When we apply that force over a specific spatial distance, we generate work and energy. Multiplying the force node by one more dimension of length gives us work and energy, ml squared t-2. Kinetic energy, potential energy, and torque all share this exact dimensional architecture. Keep in mind, while torque and energy are dimensionally identical on paper, they describe entirely distinct physical phenomena. One is a rotational twist, the other is a capacity to do work. If we need to determine the rate at which that work is being done, we divide the energy node by time. This yields power, measured in watts, with a dimensional signature of ml squared t-3. Energy and power are the concept of force, mathematically scaled across spatial distances and time intervals. We reach the most difficult leap in the matrix when we attempt to bridge the gap between mechanical motion and electrical systems. By connecting our 4th base unit, current, with time, we derive electrical charge. To bridge mechanics to electricity, dividing mechanical power by current cancels time entirely, leaving work per charge. This derives voltage, ml squared t-3 a-1. According to Ohm's law, resistance is the ratio of voltage to current. By dividing our voltage dimension by amperes once more, we reach the final stage. The result is ml squared t-3 a-2. This is the exact formula for resistance we saw at the very beginning of the video. We have successfully and mathematically linked the physical mass of an object to the electrical resistance of a wire, closing the logical loop. This brings us to the principle of dimensional homogeneity. The universe strictly enforces balance. You cannot equate joules to newtons without breaking reality. Look at this completed graph. It shows an interconnected web where all physical units stem from the same root nodes. We see this balance in action in the equation for universal gravity. Force equals big G times the two masses divided by distance squared. Physical constants exist to fix unbalanced equations. When we replace the variables for force, mass, and radius with base dimensions, we see what G needs to be. The dimensions algebraically cancel and shift, isolating G as m-1, L cubed, t-2. Big G's precise, seemingly messy SI unit is not an arbitrary number. It is the exact mathematical gear required to balance the dimensions of mass and distance with the specific output of force. Pioneers like James Clerk Maxwell recognized this underlying order. They used these measurable mathematical parameters to reliably estimate the unseen phenomena of the universe. Understanding these 7 base units provides mathematical tools to decode the universe from the ground up, proving that every physical law is part of a single, unified architecture.